would like to find the moment of inertia of the shaded area above the x-axis. What's my formula? So the moment of inertia along the x-axis, it's Ix equals the integration of y squared dA over dA. If you're doing x, you put y. If you're doing y, you're doing x. You put x. That's different from the centroid. What do we remember from what we did last time? We said we have two conditions. If we are asked to find a moment about an axis, you need to identify your dA, right? That's the most important thing, by area differential element. If you are doing it around the x-axis, you need to have it parallel to the x-axis. If it's around the y-axis, you need to have it parallel to the y-axis. If I'm going to do this here, above the x-axis, I need to create something like this. Do you agree? That's our dA. However, I told you there is a special case. That special case says if you are able to write y in terms of x all the time, don't do the horizontal. The horizontal is very complicated. Do a vertical one. So if you look at this structure, I have y equals x to the power half, correct? So my y is already in terms of x. So instead of doing that, I can do a special case in which I can eliminate this and I say, okay, fine, I'm going to do the vertical one. And use a formula for the vertical one that says Ix, that's the differential element of x, 1/3 y cubed dx. That's a special case. Moment of inertia of a vertical differential element is easy. They're asking us to find the moment of inertia around the x-axis. You need to have it horizontal to the x-axis. But I can use this special case because y is written in terms of x. Does that make sense? The only thing you need to do now is, if you have dix, so this is dix equal to 1/3 y cubed dx. What is ix? It's the integration of dix, which is the integration of 1/3 y cubed dx. Right? Plug everything in. So before we plug this, I'm integrating on dx. So what is my limits should be from where to where? 0 to 1 on the x-axis, right? On the x-axis. Now, I will say that this equals, I don't want to do this because it's a special case now. It's the integration of 1/3, what is y? Cube dx, 0 to 1. It's all we need to do. Right? So, you don't have to do this because we're doing a special case. So what I will be doing is this. This is the integration of 0 to 1, x 3 over 2. Let's put the 1/3 out, dx. This is 3 over 2. If you integrate that, I will put 1/3 out. The integration of x 3 over 2 is going to be 5 over 2. Does that make sense? Because I need to add 2 plus 2. So x 3 over 2 plus 2 over 2. That's my integration. Divided by 5 over 2. From 0 to 1. Okay. So if you have polynomial, let's say x squared, if you integrate it, it will be x cubed divided by 3. I added 1. Since my fraction is to the, it's 3 over 2, I want to add 2 by over 2. And that's 5 over 2, and then flip that. So you will have 1/3 out, and then x 5 over 2 multiplied by 2 over 5, if I flip these. And from 0 to 1, 0 is gone, so 1, 3, 2 multiplied by 1 over 5. And that equals 1, 3 multiplied by 2 over 5. That equals 2 over 15. And that's going to equal 0.1 0.33 inch to the power 4. And that's it. That's your moment of inertia around the x-axis using the special case. Last time I've solved this problem, but I used the formula. I just wanted to show you the special case how it's going to simplify around. If you try to do the horizontal, it's going to be a nightmare, literally. And it's going to take you so long to do it.